Hello, everyone. My name is Rich Ottinger, and I am the Marketing Programs Manager for Park Systems. Welcome to the fifth installment of Park Systems 2020 Material Science Research and AFM webinar series. Today's presentation topic is protective coatings. Unfortunately, due to a personal scheduling change, we have had to pre-record today's session. Therefore, we will not be able to take live questions at the end of the presentation. Please still enter your questions into the GoToWebinar questions module, or send them to me directly via email at richard@parksystems.com, and we will follow up afterwards with all of today's attendees. It is now my pleasure to introduce to you Dr. Rigoberto Advincula. Dr. Advincula is a professor of macromolecular science and engineering at Case Western Reserve University and the editor-in-chief of MRS Communications. He is a fellow of the American Chemical Society and is the author of more than 250 peer-reviewed publications. Please welcome Dr. Rigoberto Advincula.
Thank you so much, Rich, for that generous introduction. First of all, I'd like to thank Park Systems for the opportunity to deliver this content to you. And protective coatings, coating methodologies, ultra-thin coatings is something that I've been working on for the last 20 years. And I hope for some of you, this will be a new and interesting material. And for some of you who have followed my work on some time, I hope that you will have an opportunity to learn even more. But another thing is I'd like to thank you for being a part of our audience. This is a live recording, of course, as of today. But for those of you who will be able to watch this afterwards, you can also send questions by email as shown in the screen, and I'll be happy to correspond with you. So let me start by looking at this scheme with you, this view graph, which says production and integrity assurance services. Now, this might mean something that is not related to coatings, but in reality, coatings is a type of mitigation and preservation of assets for any process industry, especially when you have a lot of environmental concerns. And coatings, of course, goes from industrial to automotive to part of the architectural coating industry, as well as different types of asset integrity management. So this is a good catch-all, which says that corrosion, for example, which is one of the biggest problems in any economy or any industry, has to be mitigated by a number of channels, from effective management to different types of monitoring to different types of services, but more importantly, a coating scheme or a coating technology or project has to be part of that initial CapEx and OpEx. That means capital expenditure and operational expenditure of any industry that has to protect its assets. So let me show you then that the problem lies in environmental exposure of a lot of things, starting with carbon steel or any steel that corrodes, where you have problems either from the environment, from the fluid that's part of the process industry, or removal of waste, or specifically in the oil and gas or even geothermal industry. The problem is you have to balance between cost of the capital expenditure and the operational expenditure, which is part of the ownership proposition value. So what happens is that if you try to overprotect at the beginning, if you try to use the best materials, of course, the idea here is that you will then have not maintenance-free, but less maintenance of that asset. On the other hand, if you use cheap materials, if you use materials that are just standard or sometimes even below standard, or any type of materials that does not fit the environment of operation internally and externally, you will end up spending more for maintenance and replacement. So there's an optimum point that you need to balance these two needs. For example, in the oil and gas industry, there's a lot of transport or transportation and transmission that's going on. What we're talking about is gas or distillates or oil has to be transported from the one side to the other. So, for example, from the upstream production site all the way to the refinery. And actually, we are talking here about thousands and thousands of miles of pipes that are buried underground. And in fact, carbon steel, which we will review later, is of course the dominant transmission mode. And this is being replaced these days by non-metallic systems such as HDPE or high-density polyethylene. Another industry that's quite interesting with very challenging needs is the geothermal energy. As you can see here, the high temperature, corrosive environment, not so much with high pressure, but actually pressure plays a very important role in the presence of scaling, corrosion. This needs to be protected. That is, the assets will degrade much faster because of the Arrhenius law with regards to corrosion, or the mineralogy and the high brine condition, not to mention steam or high um, temperature three-phase fluids. So that protecting them, whether you use the best alloys or using different types of coating methods, has to be part of the project and operation. So I promise that we're going to give an overview of carbon steel. Carbon steel doesn't mean that carbon is the highest content. Of course, steel is iron oxide as well. But steel also has several types of um, metallic ingredients like chromium, cobalt, molybdenum, or these are alloys that then give a certain amount of protection. That means when we say carbon steel, what is the carbon content? The carbon content has to have a minimum amount, which then actually improves the not only corrosion, but some of the mechanical properties of the steel itself. Thus, carbon actually is a very important designation and part of what we say as steel pipes or part of the steel industry. And I will not go on to explain to you the different types of steels, except that one sometimes hear about corrosion-resistant alloys. So Inconel, Incoloy, Monel, these are some industry trade names that you may be familiar. What it is that these alloys, super duplex, etc., needs to have an amount of chromium and nickel at a specific percentage that then allows it to withstand several types of corrosion from what we call sweet and sour corrosion, meaning a differentiation between the effect of carbon dioxide, sulfur, H2S gas, etc., on the ability of these alloys to withstand corrosion. Again, this is not a talk about alloys or different types of super strength, highly resistant, even titanium alloys. That could be another talk for today. But suffice it to say, many companies, especially coating companies, tend to play a very important role in protecting these assets. And this is just a picture, a collage, if you may, of the different companies that have tried to work and supply this industry, from chemical companies, polymer companies, to formulators, distributors, applicators, individual contractors, specialty coating, etc. So just to show you that this is a very important tens and billions of dollars of industry, and again, it's part of the economy. By the way, there's a good approximation that 5% of a country's GDP is actually spent in addressing corrosion for the whole country. That means we're talking about, in the US alone, we're talking about hundreds of billion of resources spent towards preventing corrosion. So what is the importance of coatings? Well, coatings, the best way to view it is that it's not a one-way proposition or a coating that it only responds to the environment. In many ways, a coating is uh, controlled through diffusion, barrier properties, even smart properties that mitigate corrosion. But remember, the coating also has to adhere on the surface and also has the effect of containing or packaging what's on the other side of coating. So when I say coatings, I might as well be talking about automotive coatings, packaging, different types of consumer care products, or even your iPhone, because the presence of coatings enhances the uh, lifetime or product shelf life of any consumer product, but also helps preserve assets, as I mentioned earlier, or can have implication in the healthcare industry. So my work as a professor, we have also worked on a number of what we call ultra thin film coatings. So these are nano structured layers or coatings that can be controlled to less than a nanometer in thickness. So this can be done by chemical adsorption, physical adsorption, which divided into different types of coatings by layering, grafting of polymer brushes through chemical and polymer modification, or the adsorption of electrolytes, electrodeposition, and so on. Um, in fact, we specialize in a technique called polymer grafting or polymer brushes, where we combine the chemistry of doing polymerization on surfaces, whether it's carbon steel, plastics, or silicon wafer, and the ability to control the brush density of those grafted polymers, which can have many advantages in terms of the ability to control diffusion and corrosion. Another technique that we work on in the layer by layer control is by the use of polyelectrolytes and different types of adsorbing species that can be nanostructured in terms of thickness, ability to diffuse or create barrier properties, as well as improvement of specific sensory response. So what is a surface and coating engineering? So let me uh, look at it at the point of protection. First of all, a surface engineered product is meant to improve, it's meant to protect, it's meant to increase performance or reduce the cost. So, for example, many paint companies or many suppliers of protective coatings have to start from a value proposition that basically improves over existing products or creates new functionality. So that means that any surface engineering project or product has to have a good groundwork in terms of science and engineering knowledge, let's say on the action of individual contents on the formulation, or the ability to withstand extreme environments, or simply a durability that combines with the cost of the product itself. So actually, many types of materials or products are basically conversion industries. That is, you take raw materials and you try to improve on an existing application by combining these raw materials to have a synergistic combination or action that improves that performance. So let me then preface this by differentiating the different coatings available. When we talk about do-it-yourself paint, a $30 to $50 can you can buy from Home Depot or use in a lot of building construction. These are architectural coatings, and they're dominated by latex paint these days, but also epoxy, polyurethane, and others. This is something that easy to apply, but have less function in terms of protection. On the other hand, industrial and light industrial coating could be self-priming epoxy or polyurethane, has a better protective ability, and at the same time can be used in bigger projects such as industrial structures or bridges, buildings, warehouses, etc. Finishing coating has a durability of its own, but also has an aesthetic finish, and is used mostly in finishing appliances, automotive, etc. Specialty purpose coatings based on specific function, performance. Typically, these are coatings that can go into high stress environments or protecting process industries or used for the military and Department of Defense. Special purpose coatings means that they have a high performance, they are sometimes less maintenance, they can be used for environments that encounters biofouling like marine, etc. And we are not just talking here about organic or polymer coatings. We could be talking here about ceramic, metal coatings, hybrid coatings, or plasma deposited coatings, etc. In other words, this can be quite expensive as coatings, yet they do the job. And they're meant to be an investment in terms of performance. For example, the other types of coatings that we have done that might be of interest either for protective coatings or consumer products is the type of ultra thin and what I call unconventional coating. So a lot of this have been making way towards improving other types of formulation. But then a good example would be coatings on your smartphone. So a lot of you or each one of us has a smartphone. So if you ever wondered why you have smartphones that last or are smudge free or something that is of high performance. These are very, very thin coatings, typically by a curing method or a plasma deposited method that is meant to combine transparency, electromagnetic shielding, for example, and ability to, let's say, not retain or even oxidize sweat or typical organic waste or dust. So I'm not going to go on this direction for today. I could give a very specific talk on unconventional coatings, but I would like to focus actually more on industrial coatings and protective coatings that are used in a lot of asset preservation, asset integrity, and process industry. So what is a basic coating procedure? Well, you have to start with the coating composition, or maybe even synthesize all the way back to that a monomer or polymer that will give a better performance over existing series or family of binder materials. And then you need to consider the transport mode, meaning how do you take the paint from a can and deliver it to a wall? Well, you have to use a brush or a roller. That's a simple transport mode. Or if you cannot, you can use spray method, or sometimes some specialty coatings use a high vacuum. And then a substrate by which you need to deposit or order this film or control its thickness. And we're talking here earlier about carbon steel, but we might as well be talking about plastic or 3D printed parts or different types of surfaces that need good adhesion. So this is your basic coating procedure consideration. So once you have that coating technology, a majority of the coating methods out there is actually delivered as a liquid material, whether it's a liquid droplet or a paint can. That means viscosity, or here I will use the term rheology or the science of flow, needs to be considered. There are many things to consider in terms of the ability to retain that viscosity over time or various surfaces, or the curing behavior. On the other hand, the surface of the substrate itself needs to be considered. Is this a surface that can be wet or de-wetted, has de-wetting problems? Can you achieve chemical or physical adhesion? Or you can mitigate things that prevented you from getting a good aesthetic or architectural finish. So as you can see here, the delivery of a liquid material as a coating has a time limit. That is over time as the coating material dries or the solvent evaporates or you have a curing behavior, the viscosity increases. That means you only have a limited window between your application to work out a good spread or finish. And this is something that's more practical and is actually quite a important undertaking in a product development, because if you have a poor viscoelastic control, it can have problems in the field, or you can have problems or simply products that cannot be accepted by the market. Anyway, this viscosity or rheological condition actually has many types of consideration when it comes to the surface. Do the binder particles or droplets coalesce over time? We have get good wetting behavior on the surface. Is this a self-leveling material? Are there any consideration in terms of edge effects, depression, or sagging behavior? So this might sound very practical terms for industrial, yet I guarantee you, if you go to Home Depot, as much as I do, and I have to fix things, am very particular with the performance of coating products. Or you can actually be assured that even before it reaches Home Depot, a lot of science and engineering has gone on. So for those of you who like to do it yourself or DIY your projects, these are things to consider, or getting the best paint versus cheap paint. So let me use the rest of our time now to look at the major protective paints and coating materials. So I started by mentioning architectural paints, where a majority of the architectural paints are sometimes called acrylic paints or latex waterborne paints. It's because the latex particles, which are classified as your binder materials, is made actually from a type of polymerization called emulsion polymerization. And the monomers that are used are based on acrylates or metacrylates, meaning polymethyl methacrylate, butyl acrylate, or other styrene, uh, um, etc., that are produced by emulsion polymerization from forming what we call latex particles. Okay, so here is just a picture of some of the monomers that could have gone into this binder material. And a lot of these days, acrylate dispersions are actually combined with different types of formulated as well as chemistries that can harbor epoxy, polyurethane, and other types of curing behavior. Now, in the past, we heard about alkyd coatings. For the most part, this even goes all the way to ancient history. So these are paints based on oils or various types of performance oil or finishing for wood, etc. So an alkyd resin essentially involves a curing chemistry that is sometimes confused with, well, varnishing is a good um, art practice or a type of finishing, for hundreds of years. But at any rate, this type of materials are typically solvent-borne, meaning they involve the use of organic solvents to deliver and uh, give the coating consistency. There are many others here that I mention, but I'll just select a few. So, for example, polyester-based chemistry, meaning these are polyester compositions that have a curing behavior. They are a good price cost for the performance, meaning polyesters, majority of that binder polymer composition is based on a polyester. So when we say acrylate, polyester, epoxy, we're talking about the polymer binder or the polymer content of a paint material. Polyurethanes probably is more familiar to some of you who deal with industrial coatings or paint protective coatings that deliver a higher performance. So polyester, for example, you normally encounter them in automotive or finishings or even can coatings. Polyurethanes, on the other hand, is excellent for industrial grade performance and is usually bound by either a cross-linking curing mechanism, or you can have polyurethane particles or parts of the dispersion that can be combined with other chemistry. So polyurethane is a very popular material as well. And then something that combines protective properties as well as cost in a lot of applications that involves carbon steel protection is epoxy. So epoxy is found in a lot of adhesive materials as well. But when we say coatings and adhesives, the chemistry is not far from each other. So epoxy involves the oxyrane or epoxy group that is typically synthesized by reacting bisphenol A and epichlorohydrin. Once you have the epoxy group, this can then be cross-linked with, let's say, diamine or what we call co-reactant or hardener, and then that gives you a very good thermoset coating or a coating that's based on a cross-linking mechanism. And there are many types of epoxy variants, different types of hardening material. The bottom line is epoxy not only belongs to a large family of coatings, very popular also, of course, in the carbon composite or fiber composite industries. So if one were to choose right now a coating material that is good performance, cost, and overall acceptable to the market, epoxy dominates most of this. So for example, if you just paint your garage, typically that could be a self-prime epoxy coating or used in a lot of marine environments, especially for oil and gas and assets. Typically, epoxy does the job very well. Silicone, elastomeric coatings, and adhesives, they are very well known for durability, for non-wetting, for the ability to have good chemical resistance. The type of coatings based on silicone are typically elastomeric, meaning you can rely on them with zero service temperatures, for example. Phenol formaldehyde and Novolac-based resins, probably together with epoxy, constitute some of the more cost-effective methods as well. And this is very old chemistry. In fact, if you've heard of the term bakelite, this is basically phenol formaldehyde chemistry that results in very durable thermoset materials or conditions for coating. But really, the list you cannot exhaust the list that's available in the market. So epoxy, phenolic, phenol formaldehyde, polyurethane, hybrid coatings, ceramic containing epoxy, inorganic zinc, Teflon coating, or different types of dispersions of Teflon and copolymers of fluorine, highly protective coatings based on high performance polymers like PPS, etc. So all of this constitutes some of what we know as protective coatings based on polymer and hybrid dispersion. Now, of course, we will not even go at this point on metal coatings, galvanization. I mean, I will mention them briefly, but if we do not mention them as part of the protective coating selection, we will be amiss. So, for example, the use of high-performance alloys or plasma, arc weld deposited materials or metals or arc plasma spray. These are different methods of delivering metal materials as coating. So here you can see different types of coatings that are applied on the field. Actually, you can classify the application of coatings as external, internal, or you can say factory versus field. And a lot of them can be used for repair or mitigation or part of the typical fabric maintenance on surface assets. But in general, one has to deal with protection in a changing environment or specific application beyond that of the factory installed coating. So here, if we classify what would consider be a passive coating, first we can classify them as substrate, and on top of the substrate you put a primer to have a good adhesion for the intermediate coating or protective coating, and then finally a top coat that provides an extra barrier or finish on the coating material. So passive can be what you would say a 3-layer material as well. An active coating such as galvanized zinc or other types of self-healing coatings means that the damage that sometimes occur on the surface will result in mitigation of that damage by converting, let's say, zinc to zinc oxide or other types of corrosion additives, anti-corrosion additives that tend to heal the thermomechanical damage on a surface. Okay, so one can say that a coating system is actually majority of which is a multiple coat system. On the other hand, a single coat system could be a proposition for decreasing the cost. But in general, a typical coating project should involve the minimum about 50% surface preparation. Why am I emphasizing this? Well, the surface preparation probably is one of the biggest sources of failure in any coating job. If you don't prepare the surface very well, over time, the coating you added will delaminate or will degrade, and therefore you have to redo everything again. On the other hand, a very careful surface preparation, whether it's DIY or contractor driven, produces lasting coating projects. Again, you can see here a variety of coating procedures and how they can be used in the field. Here may not necessarily be failures of poor coating procedures, but for example, to mitigate based on the operating environment or procedure. Or sometimes you have to reline them or mitigate them by mechanical cleanup or coating once the product has been installed. Again, the various industries from geothermal to oil and gas transport, etc., has different requirements. So let me give a very short mention here of galvanization. Galvanization essentially is the addition of a sacrificial metal such as zinc that is first oxidized before steel. And you may be familiar with this type of finish. Yet galvanization is a very important galvanization, aluminization, or other types of um, protective metal coatings on carbon steel, which is very environmentally important. That is rain or shine, or in the absence of polymer coatings, this sacrificial layer or sacrificial materials which then oxidize to give you another coating based on an oxide, aluminum oxide or metal oxide deposition, provides that extra layer so that of protection so that the corrodant does not penetrate the carbon steel, for example. You might have heard of fuse bonded epoxy or liquid epoxy coating, or some type of coatings that can be prepared as a dispersion and then heated or cured in the factory. Epoxy coatings, of course, can be applied in the field, but the use of epoxy as part of the factory installed coating is quite predominant. I'll show you some FBE projects in a few slides. But suffice it to say, other than FBEs, cement lining, asphalt lining, polyurethane coating, these are different types of coating applications that can be factory installed. Better yet, in order to improve the mitigation of corrosion, let's say, on a material. Polyurea, elastomers, glass flake systems, hybrid materials, different types of acrylate modified epoxy, and ceramic containing materials, etc. So the list here can be quite exhaustive of what is available in the market. Again, a lot of these are converted materials, meaning from the raw materials or choice of a polymer, binder, or majority component in a formulation. Each of the additives, which can be as much as 20 additives, is meant to improve the performance of the coating over time. Okay, so as I mentioned, a lot of factory installed pre-coated polymer systems come with pipes such that they can be specified, they can be tested, and they're expected to do the job. So for example, here you can see how FBs can be prepared on a steel pipe. Essentially, the FBE is applied with the heat or heated pipe. The FBEs are epoxy cured coatings. So you have epoxy and the heat together with the hardening that is introduced results in a very durable coating that can be even applied in the interior of a carbon steel, meaning FBEs can actually be used to mitigate corrosion inside the pipe, or the insertion of liners or pipe within a pipe sometimes are employed to give a higher durability against corrosion. Uh, for example, other types of polyethylene and outer protection coatings other than the pipe itself can be used to expand the durability of these pipes on the field. So, for example, and of course, one can do away with carbon steel itself by using non-metallic materials, or HDPE itself can be the pipe. So, in other words, you have a lot of choices for protective coatings during the application. Now you're familiar with galvanization. So, can you apply or do a DIY with zinc-rich composition? Yes, you can. Zinc and aluminum-rich composition can come in the form of paint, spray paint, or deposited by heat as particles or dispersion. Pipe coatings, for example, also have insulation properties, and I encounter a lot of these products or projects in the geothermal industry, and a lot of them are built to withstand higher temperature. They from Novalac to epoxy or Novalac epoxy compositions, and therefore including ceramic materials. They can withstand very high temperatures, but sometimes not chemical durability. Again, the list can be exhaustive, so I'll just skip some of this. Um, Glass flake formulation, for example, can help improve some of the thermomechanical properties and resistance to wear. Um, Let me skip this and go towards repair. So one thing that one has to counter as part of the paint industry is, of course, providing products that can be used for repair, or that once the damage has been done, can you apply a repair kit, or can you reapply a coating on the field? And there are many companies that have specialized products, especially for the pipes, buried pipes, and even marine application. And you can see here, you can use sometimes heat shrink sleeves or thermoplastic coatings or different types of wrapping materials that can be used to repair leaks or prevent future leaks or simply mitigate the possibility of leak. And I've encountered a lot of this both from the oil and gas and, let's say, even the geothermal industry. Liners, on the other hand, although strictly this one can say this is not a coating yet, as a method, this is gaining popularity, especially for municipal sewage and water pipes, because liners essentially are polymer materials or fabrics that can be used to insert them on existing carbon steel pipes, pressurized, expanded, and therefore the shape is already determined by the corroding pipe, but the liner provides a fresh surface or coating, if you still want to use that, for the fluid to flow. So there's a lot of contractors, formulators, and developers for this type of mitigation. And then finally, again with metals, one can insert liners or coat them with fuse bonded epoxy or alloys. And the reason one can use, for example, liners or a 2 diameter or bored pipes is that simply by inserting another pipe, you basically again take the advantage of the mechanical support provided by carbon steel, and then have a corrosion protection based on a thicker diameter inserted pipe or liner that basically handles the fluid that goes to it. So while not strictly speaking it as a applied coating material, yet liners, pipe, um, pipe within a pipe proposition, or the insertion of different types of preformed materials that can mitigate chemical or corrosion attack is actually part of the coatings industry. And so with that, I hope I've had an opportunity to give you a very good overview of the coating industry. And again, I hope this is very useful to you, and something, again, I'd like to thank Park Systems, developer of some of the best AFM products out there to use. So with that, I'd like to thank you, and I'll be happy to take questions. You can send that through Park AFM, or send it through my email, and we'll be happy to connect with you. Thank you.
Thank you, Dr. Advincula, and thank all of you for joining us for today's webinar. Once again, if you have a question, you can still type it into the questions module on the GoToWebinar panel. I will take this opportunity to ask one question, which is, can you give us a brief preview of next month's webinar topic, flow chemistry and polymerizations?
Yes, appreciate that, Richard, for the reminder. We will be talking about chemistry of pressurized and flowing systems. This in particular should be of interest to a lot of you who are involved with synthesis, but polymers in general, understanding in a chemical environment, the application of high pressure and temperature can improve the control on the kinetics of the reaction, and therefore can result in higher percentage yield. So with that, again, I'd like to invite you to participate in that webinar, and I hope that you will learn and get something new. Thank you.
Thank you, Doctor. Please join us for that session on Friday, August 21st, once again at noon Eastern Time. Thank you all for joining us for this session. You can find more information about Park Systems AFM at parksystems.com, and please direct any AFM questions you have to inquiry@parksystems.com. If you have any questions specific to this webinar, feel free to reach out to me directly at richard@parksystems.com. To stay up to date on all of our upcoming webinars, online live demos, and workshops, please go to parksystems.com/online nanoacademy. Thanks again for joining, and stay safe, everyone.